Today we are going to talk about fractional unit rates. We have already learned how to find the unit rates, but now we are going to throw fractions into that. We're always going to start off by writing our word ratio. It's incredibly important to make sure that we have what we are comparing written out. That way we can make sure that it stays consistent throughout our entire process. After that, we will write our complex fraction. I will show you what that looks like in a second, but basically it is a fraction over a fraction. So this is a complex fraction here. And then we would have our units as well since we're working with unit rates. We then move on to KCF, keep, change, flip, to divide our fractions. Then we move to evaluate and answer with our units. So let's go ahead and give this a shot. It says if 1/3 of a gallon of paint covers 1/9 of a gate, then how many gallons of paint are needed to cover an entire gate? So the first thing that we want to look for is we need to be able to write our word ratio. So we want to know what we want one of. Remember that with unit rates, we always have a 1 in our denominator. So we need to think, what do we want one of? Well, here, how many gallons of paint are needed to cover the entire gate? So we want one full gate. Therefore, gate goes on the bottom of our word ratio. I always like to find what I want one of and box it or underline it, highlight it in some way to help me keep myself in check. From there, the other thing we are comparing is gallons of paint. So I'm going to write gallons. Okay, so that's my word ratio. I have my word ratio. Now I move to my complex fraction. So like I said, we will have a fraction on top of a fraction. So I start with my gallons. I want 1/3 of a gallon. So 1/3 gallons. Remember, this is unit rates. So we do need to include our units. And we will divide that by 1/9 of a gate. So we have a paint, we have 1/3 gallons, so that's part of a gallon, and it covers this much of our gate. Now our goal is to see how much one full gate would be. Okay, so from here, we have to do KCF. So remember, this is a division bar, also a fraction bar, but it also symbolizes division. So we have 1/3 divided by 1/9. Okay. From here, we do KCF. So we set up our division problem. I use KCF to turn it to multiplication. 1/3 times, flip that second fraction, 9/1. Next up, I evaluate. So I can simplify. 9 divided by 3 is 3. 3 divided by 3 is 1. So 1 times 3 is 3. 1 times 1 is 1. This is the top part of my fraction. So I would say 3/1 gallons per one gate. But because that's a whole number, I can get rid of that when I write my actual answer. So I would say 3 gallons per one gate, or for an entire gate. Okay, now sometimes this might be an actual fraction. So you would say, like, let's say it was 2/3, you would say 2/3 gallon per one gate. So we start with our word ratio, complex fraction, KCF. We take our complex fraction and write it out horizontally to be able to divide our fractions. We evaluate and then write our answer. Again, this is unit rate. You must have units. All right, let's try a second problem. Okay, it says Jackson eats 1/4 of a banana in 1/2 minute. How much time will he need to eat a full banana? So we remember that our very first step is to write our word ratio. We need to know what we want one of, so that can go on the bottom. Awesome. So what do we want one of here? Jackson eats 1/4 of a banana in 1/2 a minute. How much time will he need to eat a full banana? What do we want one of? Yeah, we want a full banana, one full banana. I don't want to know 1 minute. So I'm going to go ahead and put banana on the bottom. That means minutes go on top. What is our next step here? We want to write our complex fraction. Now, having this word ratio here is going to help keep us in check. That means, see how we have here that the banana comes first when we read? A lot of times students will then automatically put that on top, but that's not the case this time. The 1/4 belongs to the banana, which is in the denominator. So we need to pay very close attention and make sure we're following our word ratio. Then for minutes, we've got 1/2 minutes. Okay, so now minutes over bananas, 1/2 minutes divided by 1/4 of a banana. So my next step is to do KCF. What will my division sentence look like? What will my division problem look like for this? Well, we've got 1/2 divided by 1/4. Now I do KCF. So I keep my first fraction, change my division to multiplication, and flip my second fraction. Now I have 4 over, I can divide 4 by 2, which will get me 2, and 2 divided by 2 is 1. So 2 times 1 gets me 2. 1 over 1, or 1 times 1, is 1. Again, sometimes this might not lead to a whole number. In this case, it does. So it tells us that our answer is 2 over 1 minutes for 1 banana. Because this is a whole number, we would then write 2 minutes per banana as our answer. Again, this might be a fraction. So remember that this will always be what goes in our numerator. This whole thing goes to our numerator. And then 1 of our bottom of our denominator piece is always on the bottom. All right, why don't you try this one? It says Mike ran 1/2 mile in each 1/7 of an hour. How far did Mike run in 1 hour? Go ahead and solve this now. You will type your answer into the box. So your answer for this is that Mike ran, you could say, it says 7/2 miles, 7/2 miles per 1 hour. But then you could translate that to say 3.5 miles. If you do leave it like this, that's okay. This is more common language that we use typically.